everyone, Miss Patsy here at Castile Innovation Lab. Today we are going to be studying from the 4th grade science book called Energy, Investigation 3, Electromagnets, Part 1, Building an Electromagnet. Question: how can you turn a steel rivet into a magnet that turns on and off? Let's find out. Have you ever seen a junkyard crane before? It uses a giant magnet to pick up items from one location and takes it to another location. But I can't make this magnet let go of my items. So how do I create a magnet that can pick up and release? Do you remember our investigation on induced magnetism? I can make this an induced magnet by applying a permanent magnet to one end. And when I needed to release the washers, all I need to do is to remove the magnet. Can you think of a better way to induce magnetism in our rivet? Our focus question for today is, how can we turn a steel rivet into a magnet that we can turn on and off? For today's investigation, we will be using a rivet, 20 gauge wire, 24 gauge wire, some washers, a D-cell, a compass, a wire cutter, a circuit base, and some magnets. First, let's start with our wires. I have a 24 gauge wire that I cut at 150 centimeters long. I'm going to cut off the insulation, 2 centimeters of the insulation on one end by putting it in a notch and pulling it off. So this end of the wire is now exposed. I do that to both ends of the wire. Next, I'm going to take my rivet and wrap my wire around this end between the rubber and the head. I'm going to leave about 20 centimeters of wire sticking out and wrap the other one around 40 times. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Now I will add my rivet to my circuit board by attaching one end to the D-cell and the other end to the switch. Now let's see if our magnet works. Now, why do you suppose our magnet doesn't work? Well, that's because we haven't made a full circuit. We have part of the circuit here, but this end to this end is still open. So we need to complete that circuit. So I'm going to use my other wires to complete this end of the circuit. Now we can test our magnet. But it still doesn't work. What could the problem be now? Well, do you see this switch? It is flipped open. Kind of like the light switch in our home. When it's in this position, no electricity can flow from this joint to this joint. When we close the switch, electricity can now flow from here to here and close the circuit. So now let's see if our magnet works. This is called an electromagnet. An electromagnet is made when the flow of electricity through an insulated wire produces electromagnetism. The electricity flowing through the wire around the rivet makes it an induced magnet. The rivet is called the core, and the wires around it is called a coil. Now, to release our items, all we have to do is open the switch to interrupt the electricity flow, and all of the items drop. So what are the functions of our components? What is the function of the D cell? Well, that is our source of energy. What is the function of the wires? Well, the metal inside conducts electricity. What is the function of the steel rivet? It is an induced magnet. Here's a question. What if I want to make my electromagnet stronger? How would we go about doing that? First, let's test our current electromagnet. Currently, we can pick up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 washers. How would I go about making my magnet stronger? One solution is to add more energy. So let's add another D cell to our circuit. And see if that increases the energy. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So by adding the extra D cell, I was able to increase the number of washers we were able to pick up with our electromagnet. To summarize, when electricity flows through a circuit, a magnetic field is produced around the wire. Because the wire is covered by insulation, electricity does not travel into the core, but the magnetic field does. Now the core is in a magnetic field and it becomes a temporary magnet that you can control by turning on and off the electricity. The core is an electromagnet when the current flows. Now you know how to turn a steel rivet into a magnet that turns on and off. I hope you enjoyed this investigation. Until next time, have a great day.